Hello friends, once again welcome to chemistry classes by Vijay Kumar Sethi, class 11th chemistry. We were discussing unit 9 hydrogen, and in this video we will discuss about chemical properties of water. First one is amphoteric nature of water. Water has the ability to act as an acid as well as a base, that is, it behaves as an amphoteric substance. In the Bronsted sense, it acts as an acid with NH3 and a base with H2S. We already discussed the Bronsted and Lowry concept of acid and base. According to that concept, the proton donor substances are known as Bronsted acids and proton acceptor substances are known as Bronsted base. When water reacts with the NH3, it donates the proton to NH3. See this reaction. This is H2O. After donating proton, this will convert into OH minus ion. So this is acid. But when this reacts with the H2S, it accepts the proton from H2S, and after accepting the proton, this H2O is converting into H3O plus. So in this reaction, this is acting as base. Okay. So we can say these two reactions represent the amphoteric nature of water. The autoprotolysis or self-ionization of water takes place as follows. This amphoteric nature can also be explained by this self-ionization. In this reaction, one water molecule donate the proton and another water molecule gain that proton. Okay. So see, in this case, this H2O. This H2O will act as acid because this is donating proton, and after donating proton, this will convert into this OH minus ion. So OH minus ion is the conjugate base of this acid. And this H2O, this will accept the proton, so this is a base, and after accepting proton, this will convert into H3O plus. So this H3O plus is a conjugate acid of this water molecule. Okay. Now redox reactions involving water. Water can be easily reduced to dihydrogen by highly electropositive metals. For example, when water reacts with the sodium, NaOH is formed along with the liberation of hydrogen gas. Thus, it is a great source of dihydrogen. Water is oxidized to oxygen during photosynthesis. This is the reaction occurring in photosynthesis. 6CO2 plus 12H2O converting into C6H12O6 plus 6H2O plus 6CO2. Plus 6O2. Dear student, in the lower class, you have discussed the photosynthesis reaction like this. 6CO2 plus 6H2O, and this is converting into C6H12O6 plus 6O2. Okay, this you have discussed in the lower class, but in this class you are studying this one. What is the difference between this one and this one? Just see carefully. In this case, in the reactant side, we have taken 12 water molecules. In the product side, again 6 water molecules are formed. What is the reason behind this? Actually, when mechanism of photosynthesis is find out, then it was explained that these oxygen molecules are coming from the water, not from carbon dioxide. Clear? And in this 6O2 means 12 oxygen atoms are there, and so there are 12 water molecules because each water molecule give one oxygen atom. Clear? So we write this photosynthesis reaction in this way. With fluorine also it is oxidized to O2. Reaction is 2F2 plus 2H2O, and on reaction we will get the HF, but HF when dissolved in the water, this will give H plus ion and F minus ion. So this is written as 4H plus 4F minus along with the oxygen. Hydrolysis reaction. Due to high dielectric constant, it has a very strong hydrating tendency. It dissolves many ionic compounds. However, certain covalent and some ionic compounds are hydrolysed in water. See reaction. P4O10 when react with the water, it forms phosphoric acid H3PO4. When SiCl4 react with the H2O, SiCl4 is hydrolyzed to give SiO2 plus HCl. The same way, this is nitride N3 minus ion. When react with the H2O, it will form NH3 plus 3OH minus. Hydrates formation. From aqueous solutions, many salts can be crystallized as hydrated salts. Such an association of water is of different types, namely coordinated water. For example, CrH2O6 3 plus 3Cl minus. Actually, this compound is a coordination compound. Okay, and in this case, these water molecules are coordinated, bonded with this chromium. Now, what is this coordination bond? Okay, we have discussed about the covalent bond. Just see, in covalent bond, a bond is formed by sharing a pair of electron. Okay, this is a covalent bond. In this pair of electron, one electron is shared by this one and one electron is shared by this one. Okay, but if we consider, this is NH3, and when this is react with the proton, then this will convert into, this is NH4 plus. Okay, now actually you can represent this. Actually, this is a covalent bond between these 3 hydrogen atoms and nitrogen. This is ammonia. Okay, NH3, this one. But when this H plus is added to this one, proton, that is, it does not have any electron pair. Okay, so this electron pair, lone pair of electron present on the nitrogen, this is donated to this H plus. Okay, this is donated by this nitrogen. In this electron pair, that is, again, this is the bonded pair of electron, there is no contribution of electron from this hydrogen side. So this type of bond in which, this type of the covalent bond in which the bonded pair of electron is given by only one of the bonded atom, that is known as coordination bond. Okay, and this coordination bond is generally represented like this one. Okay, and these are the normal covalent bond. This arrow mark represent that lone, that is, electron pair is donated by this nitrogen to this hydrogen. Okay, but after the forming this coordination bond, this behaves like a covalent bond. So in this water molecule is coordinated, bonded with chromium. Next one is interstitial water, BaCl2.2H2O. Now again, this is what is interstitial. When any crystal is formed, crystal of any solid substance is formed, there is just some space between that crystal. That is known as interstitial space. When these water molecules occupy this space, then that water is known as interstitial water. Okay. Next one is hydrogen bonded water. See the example, CuH2O4 2 plus SO4 2 minus dot H2O. In CuSO4 dot 5H2O, this formula of copper sulfate you have discussed in the lower class, copper sulfate pentahydrate. Okay, in this case these 5 water molecules are there, but only one water molecule which is outside the bracket, that is this one, okay, is hydrogen bonded. Out of 5 water molecule, only one water molecule is hydrogen bonded, and the 4 water molecule which are written in this square bracket, these are coordinated bonded. Okay, and this, we can say the part which is written in this square bracket, this is known as the coordination sphere. Okay, more detail we will discuss in the class 12th in the chapter coordination compounds. Okay, these are the chemical reactions of water. Thank you.